let's find the general solution to this differential equation. So this is a first order linear differential equation. So I could apply the integrating factor to solve this differential equation. So the integrating factor method dictates that my differential equation must be in the form y prime plus p of x y equals to q of x. Now I almost have that in my differential equation. However, I can see that my y prime is multiplied by x. So let's just get rid of that by just dividing both sides by x. So now when I do that, I get that my differential equation is equal to y prime plus 4 over x times y, because I divided by x. And then dividing my right-hand side by x, I'm left with just 5. Now that I have this in the general form, I have identified my p of x, which is 4 over x, and my q of x, which is 5. Now, I'm going to find my integrating factor. I'm going to call my integrating factor mu. So I know some people call it I of x or rho of x, but it doesn't really matter as long as you know what it is. And it's equal to e to the power of p of x dx. Now, I already know what my p of x is, so I just have to plug it in. So it's e to the power of the integral 4 over x dx. Let me just blow up this integral to see what it is. Now, integrating 4 over x dx is very simple. It's just 4 natural log of x. And we know that this is all raised, it's e to the power of all that, so 4 ln x. Using my log rules, I could rewrite this as e to the power of natural log x to the power of 4. And now, again, using another log rule, I know that this kind of goes away, so that I'm left with x to the power of 4. And that's my integrating factor. Now that I have my integrating factor, what I'm going to do is multiply it by both sides of my differential equation. So now when I multiply my integrating factor, I'm going to have x to the power of 4y prime plus 4 over xy times my integrating factor x to the power of 4, and then also multiplying that 5 by the integrating factor, and this is what I have. Now, I want you to just look at the left-hand side of my equation and take a minute to see if anything looks familiar. Now, the trick with the integrating factor is that this left-hand side should be equal to a product rule of something. So if you could notice, we have x to the power of 4 multiplied by the derivative y prime. And then on the other side, I have the derivative of x to the power of 4, which is 4 times x cubed, because if I divided that x with that x to the power of 4, this is equal to 4x cubed times y, right? Which is equal to the derivative of x to the power of 4 multiplied by y. So that is the product rule of x to the power of 4 times y. So I could just rewrite this as one term, which is the derivative of x to the power of 4 times y equal to 5x to the power of 4. Now the whole purpose of this integrating factor comes from the name, is to just turn your differential equation into something integrable, which is what I could do now. Because if I just took the derivative on both sides, I know that because this is a derivative, I could utilize the fundamental theorem of calculus and know that this all is just equal to x to the power of 4y, right? Because this is a derivative and I'm integrating it, so I'm just left with my original function. And then integrating my right-hand side, I just apply the power rule, so 5x to the power of 4, I add 1 to the x to the power of 4, so it's 5 times x to the power of 5 divided by that new power, so that 5 goes away, adding my arbitrary constant c. I don't think I mentioned this earlier. When you're integrating this part, when you're integrating to find your integrating factor, you don't need to add your arbitrary constant c. You do that at the very, very last step. So here. And now, just to rewrite this in a nicer way, this is what I have. I just have to take one more step to isolate y and find my general solution so that I could just divide by x to the power of 4. So this y is isolated, so y is going to be equal to x over 5 divided by x to the power of 4, which is just x. And then c divided by x to the power of 4 can be written as just that. Or if you want to write it in a nicer way, it would be c times x to the power of negative 4, which is the same thing. But when you do that, you find your general solution to your differential equation, and that's it.